All right, almost done with lesson 6.7. I know it's a long one. And what we're going to do is we have two examples to do, number 9 and number 10. In both of these, what we want to do is write a polynomial function of least degree with integer coefficients given some particular zeros. So where we left off is we had two particular roots, -5 and 3i. We know that the imaginary roots come in complex conjugates, so that means our factors are going to be x plus 5, x plus 3i, and x minus 3i. So we're going to set that up in a polynomial function. So that means we're going to have f of x is equal to x plus 5 times x minus 3i, x plus 3i. Now, we have to start multiplying, so what I'd like you to do is turn off the video, multiply these out, and turn it back on when you're ready to check your answer. When you are ready to check your answer, you should have the definition of function f of x all multiplied out. Remember to put the terms in order of decreasing degree. I will show all the steps just in case you need to see them. So turn the video back on when you've multiplied it all out. Okay, so we've been able to determine that f of x is equal to x cubed plus 5x squared plus 9x plus 45. Really, all we did is we multiplied and then we substituted in for I squared. We know that Okay, question number 10, example number 10 is very similar to number 9, although our zeros look a little bit different. We know that if our 0 is x is equal to 4, then in order to turn this into a factor, we bring that 4 over and we have x minus 4 is equal to 0. So that gives us one of the factors. In the case of the complex factor, we have x is equal to 4 minus I. And remember that we're going to have the plus or minus going, but I'm going to leave it this way for the moment. And bring everything over so that it is equal to 0, and we're going to have x minus 4 plus I is what we're going to have as equal to 0. And it could be plus or minus on the I term. So those are the three factors we're going to set up right away with our f of x. Okay, so here we've got our three factors set up that we came up with, and what we're going to do is multiply the complex factors to each other first, because we know we're going to end up with an I squared term that will drop to a -1, and then we'll multiply the result of that once we've simplified to the x minus 4. So let's get started on that. This is going to be equal to x minus 4, and then let's start multiplying. So we're going to have x times x, x squared, and then minus 4x, and then minus xi. Okay, next we're going to multiply that -4 term, so we're going to have minus 4x plus 16 and plus 4i. We need to multiply that last I to everything in the green, so we're going to have plus xi minus 4i and minus I squared. Okay, you can see we have a lot of things. Whoops, I need a parentheses. A lot of things to combine here, and let's just very quickly mark the like terms. Okay, so I've highlighted the like terms. We know that there's only the one x squared term, but we have several terms that have x. We have negative 4x minus 4x again. That's going to end up giving us a minus 8x. Let's see, x squared. And then we have the xi. We have minus xi, and then we have plus xi, so those are going to fall out. And then we have the plus 16, and we have the minus I squared, which we know I squared is equal to -1, so that's going to give us eventually a plus 1. So here we've got x squared minus 8x plus 17. We're not done multiplying. We need to go one more round, and we're going to end up with x cubed minus 8x squared plus 17x minus 4x squared plus 32x, whoops, and minus 68. So once again, combine like terms, make sure everything is in the proper order. We know that f of x is equal to x cubed minus 12x squared plus 49x minus 68. All right, and now, ladies and gentlemen, we are done with section 6.7. Congratulations.